Imagine a force so powerful that it's pulling entire galaxies, including our own Milky Way, through the universe at millions of kilometers per hour. Something invisible, mysterious, and massive, lurking in the cosmic dark. Scientists can't see it directly. They only know it exists because of the way it drags everything toward it. It's called the Great Attractor. And NASA warns it's one of the scariest discoveries ever made in space. What is it? Where is it? And what could it mean for us? Stay tuned, because the answers will blow your mind. Imagine a force so powerful that it can move entire galaxies through the vast emptiness of space. This is not science fiction, this is reality. Astronomers have discovered that the Milky Way, our home galaxy, is being pulled toward a mysterious region of the universe at an astonishing speed of about 2 million kilometers per hour. That's millions of times faster than any rocket humans have ever built. And yet, we cannot see this force directly. This invisible powerhouse is called the Great Attractor. It doesn't emit light. It doesn't radiate energy like a star or a galaxy. All we know about it comes from the way it influences the motion of galaxies around it. When scientists mapped the movements of galaxies, they noticed a strange pattern. Many galaxies, including ours, were not simply drifting with the cosmic expansion. They were being tugged toward the same point in space. Something massive, something unseen was pulling them with incredible force. The very idea is staggering. Think about it, an invisible entity, millions of light years away, controlling the motion of everything in its reach. It is like a giant hand in the cosmic darkness, guiding the galaxies toward it. And the scale is almost impossible to comprehend. Galaxies are unimaginably massive, each containing billions of stars, planets, and countless other celestial objects. And yet, even they are being swept along by the gravitational pull of this unseen attractor. For decades, scientists tried to locate the Great Attractor. Telescopes around the world scanned the sky, trying to find a cluster of galaxies or a massive object that could explain this cosmic movement. But much of it lies hidden behind thick clouds of gas and dust in a region of the sky astronomers call the zone of avoidance. This makes direct observation nearly impossible. Instead, scientists rely on indirect measurements, tracking the motion of galaxies and inferring the presence of this enormous gravitational source. The discovery of the Great Attractor changed the way we understand the universe. It reminds us that space is not a passive void. It is alive with forces we cannot see, pulling and shaping the motion of galaxies over billions of light years. The Milky Way, our solar system, and countless other galaxies are all participants in this cosmic dance, moving along a path dictated by a force we are only beginning to understand. Some might find it terrifying to think about. We are hurtling through space towards something unknown, a region of the universe that may contain secrets far beyond our imagination. Yet there is also wonder in this discovery. The Great Attractor challenges us to look beyond the familiar, to explore the invisible forces that govern the cosmos, and to expand our understanding of reality itself. NASA and other space agencies continue to study the Great Attractor using advanced instruments like infrared telescopes and X-ray observatories. Each observation brings us closer to understanding how such an immense, unseen force can exist and what it can teach us about the universe. And while it remains a mystery, it also represents the incredible capability of human curiosity and scientific exploration. In the end, the Great Attractor is a humbling reminder. No matter how much we think we know, the universe is full of forces beyond our perception. Entire galaxies, including our own, are being guided by something invisible, something colossal, something we have yet to fully understand. And that realization, both frightening and awe-inspiring, is why the Great Attractor remains one of NASA's scariest and most fascinating discoveries. Even though the Great Attractor has such a massive influence on the motion of galaxies, we still cannot see it directly. Much of it lies hidden in what astronomers call the zone of avoidance. This is a part of the sky that is completely obscured by thick clouds of gas, dust, and stars in our own galaxy. These clouds block the light coming from objects behind them, making it almost impossible for traditional optical telescopes to detect what lies beyond. It is as if a massive curtain is hiding one of the universe's greatest secrets from our eyes. To study the Great Attractor, scientists have had to get creative. They use indirect methods to map its presence. One of the main tools is to observe the movement of galaxies. When galaxies are being pulled toward something massive, they speed up and change their direction. By measuring these subtle changes, astronomers can infer the location and size of the hidden object causing the pull. Even though we can't see the Great Attractor directly, its gravitational fingerprint is unmistakable. Infrared and X-ray telescopes are crucial for peering into this hidden region. Infrared light can pass through dust clouds that block visible light, allowing scientists to detect stars and galaxies otherwise invisible. X-ray observations reveal extremely hot regions, like massive galaxy clusters, which could be part of the gravitational source. Each new observation provides a piece of the puzzle, slowly revealing a picture that is still incomplete but profoundly fascinating. The zone of avoidance makes the great attractor even more mysterious and, for many, frightening. It reminds us that the universe is full of hidden forces and objects that exist beyond our perception. We are literally being pulled by something we cannot see, in a region we cannot fully explore yet. It is a cosmic tug of war where the other side is invisible, and we are only beginning to understand the rules of the game. Astronomers also discovered that the great attractor is not a single object, but a vast region of space containing countless galaxies and possibly enormous amounts of dark matter. Dark matter is an invisible substance that does not emit, absorb, or reflect light, but its gravity affects everything around it. The combination of these hidden galaxies, galaxy clusters, and dark matter could explain the enormous gravitational pull we observe. Yet much of it remains uncharted territory. The difficulty in observing this region highlights a major challenge in astronomy. Most of the universe is invisible to the naked eye. We live in a small, luminous bubble surrounded by darkness, and only with advanced technology can we begin to understand the forces shaping the cosmos. The great attractor sits at the edge of what we can currently detect, in a zone that is literally avoided because of its obscurity. This makes it one of the most intriguing and mysterious targets for scientists today. The mystery also inspires curiosity and exploration. Even though we cannot see the great attractor directly, its effects are undeniable. By studying it, astronomers hope to learn not only about its structure and composition, but also about the dynamics of the universe itself. How do galaxies form, move, and interact on such an immense scale? What hidden forces shape the cosmic web? The great attractor is a doorway to these answers. In the end, the zone of avoidance is both a literal and symbolic reminder of the unknown. It represents the limits of our current understanding and the exciting potential of discovery. The great attractor lurks in the cosmic dark, invisible yet undeniable, shaping the universe in ways we are only beginning to comprehend. It is a mystery that combines fear, fascination, and awe, forcing us to look beyond the familiar and reach for knowledge hidden in the shadows of the cosmos. When we talk about the great attractor, one of the most mind-blowing aspects is its sheer scale. This is not a small cluster of galaxies we can picture easily. It resides within the Laniakea supercluster, a colossal cosmic structure that stretches over 500 million light years. To put that into perspective, 1 light year is almost 10 trillion kilometers. This means the great attractor's influence spans distances that are virtually impossible for the human mind to imagine. The Laniakea supercluster is home to tens of thousands of galaxies, all moving in a gravitational ballet choreographed by the great attractor. Our own Milky Way is part of this supercluster, slowly being drawn toward this mysterious region along with millions of other galaxies. Imagine a current in an endless ocean pulling countless ships in the same direction, but the current itself cannot be seen, only felt. That is what the great attractor does on a cosmic scale. The vastness of the great attractor also reveals how tiny and fragile our galaxy truly is. In the grand scheme of the universe, the Milky Way is just one of countless galaxies being tugged along by an invisible force. Despite its billions of stars and immense size, it is still a mere passenger on a journey directed by something far larger and more powerful. Thinking about this scale can be both awe-inspiring and terrifying. Scientists estimate that the great attractor has a mass equivalent to millions of billions of suns. Its gravitational pull is so strong that it dominates the motion of galaxies within hundreds of millions of light years. Every galaxy in its reach, including ours, is part of this cosmic migration. Yet, even with such incredible mass, the great attractor remains mostly invisible to us. It is hidden behind cosmic dust and may contain enormous amounts of dark matter, which cannot be seen but exerts a powerful gravitational force. The scale of this structure challenges our understanding of the universe. It shows that galaxies are not scattered randomly, but part of a vast cosmic web interconnected by gravity and influenced by massive hidden forces. The great attractor is like a node in this web, a colossal gravitational hub around which galaxies orbit and move. Mapping this web helps scientists understand the large-scale structure of the universe, how it formed and how it evolves. Studying something this vast is no easy task. Astronomers must rely on observations of galaxy movements, infrared surveys, X-ray telescopes, and sophisticated computer models to piece together the puzzle. Each discovery adds another piece to the cosmic map, revealing not only the great attractor itself, but also the immense network of galaxies and superclusters that surround it. Even today, we are only scratching the surface of this enormous cosmic structure. The sheer size of the great attractor also forces us to rethink our place in the universe. It reminds us that our solar system, our galaxy, and even our supercluster are just tiny components of an almost unimaginably vast cosmos. Forces far beyond our perception are shaping the destiny of galaxies over billions of years. It is humbling to realize that while we measure time in years and decades, these cosmic currents move over scales of millions and billions of years. In the end, the scale of the great attractor is both terrifying and awe-inspiring. It shows us that the universe is not just vast, it is structured, interconnected, and driven by invisible forces beyond our direct observation. Understanding this scale is crucial to understanding the universe itself, and it reminds us how much there is left to discover. The great attractor is a cosmic giant, and in its shadow, our galaxy drifts, part of a journey billions of years in the making. The most mysterious and intriguing part of the great attractor is what it could mean for our understanding of the universe. Even after decades of study, astronomers are still unsure what exactly lies at its core. It may be a massive cluster of galaxies, a concentration of dark matter, or even something far stranger that challenges the limits of modern physics. This uncertainty is both exciting and unsettling. We are being pulled by something enormous and unknown, and yet we cannot see it directly. One possibility is that dark matter plays a central role. Dark matter is invisible, it doesn't emit light, and we cannot detect it with conventional telescopes. Yet it makes up most of the mass in the universe and exerts a gravitational influence on everything around it. If the great attractor contains vast amounts of dark matter, it could explain why it exerts such an enormous pull on millions of galaxies. We are witnessing the effects of a force we cannot see, a reminder that most of the universe is hidden from our eyes. Another possibility is that the great attractor is part of an even larger cosmic structure. Some scientists speculate that it might connect to other superclusters or vast cosmic filaments, forming a network that spans billions of light years. If true, it would show that the universe is far more interconnected than we ever imagined, and that galaxies are not drifting randomly, but moving along invisible highways guided by gravity. This challenges our sense of cosmic scale and order. The great attractor also forces us to confront our own insignificance. The Milky Way, our solar system, and even Earth are just tiny players in this vast cosmic dance. We are hurtling through space toward a destination we cannot see, at speeds we can barely comprehend, pulled by forces we do not fully understand. It is humbling and, for some, terrifying to realize how small and fragile we are in the grand scheme of the universe. Despite this uncertainty, the great attractor inspires curiosity and scientific exploration. It is a puzzle that drives astronomers to develop new technologies, create more powerful telescopes, and design sophisticated simulations of the universe. Each new discovery brings us closer to understanding the forces shaping the cosmos. It reminds us that science is not just about finding answers, but about asking the right questions and being willing to explore the unknown. The study of the great attractor also highlights the limits of human perception. Most of the universe is invisible to us. We can only see a tiny fraction of galaxies, stars, and matter. Forces like the great attractor remind us that the universe operates on scales and in ways that challenge human intuition. It encourages us to look beyond the visible and consider the invisible forces that shape reality. At its core, the great attractor represents both fear and wonder. It is a force we cannot control, a mystery we cannot yet solve, and a reminder that the universe is far more complex than we imagine. But it also sparks excitement. Every step closer to understanding it is a step toward uncovering the hidden architecture of the cosmos. It encourages exploration, discovery, and imagination. In the end, the great attractor is more than just a cosmic anomaly. It is a symbol of the unknown, a challenge to human curiosity, and a reminder that the universe is vast, interconnected, and full of mysteries waiting to be solved. It pulls galaxies, including our own, toward it, guiding the motion of millions of stars and planets, while remaining invisible and largely unexplored. And that is why it continues to captivate scientists and the public alike, combining fear, fascination, and the thrill of discovery in one colossal, mysterious force.